Welcome to KubeCon. Super excited. If this is your first talk of the day of the conference, we're happy to kick it off for you. My name is Kendall Roden. I am a product manager at Diagrid. Previously was at Microsoft and have been working on the open source Dapr project for about 4 years now.
Hi, I'm Mathieu Benoit. I'm a Cloud Native ambassador. Oh, could you hear me now? Yeah. Hi everyone, I'm Mathieu Benoit. I'm Cloud Native ambassador, Score maintainer, and customer success engineer at Humanitec. Very glad and excited to be here with you today.
Awesome. So today you've come to hear about mixing the perfect cocktail. A little too early to actually give you one, unfortunately, but we'll make sure that you have a good time today and learn a lot about Dapr and Score. So just want to set the context a little bit about the current state of the world as I know it, and as probably many of you know it as well, right? Platform and infrastructure concerns have become progressively more apparent to developers and bleed into the inner loop development process, right? Additional dependencies, new libraries, new concerns that come when you break an application across the network. And when you introduce large-scale development, you have to start to find ways to help abstract away some of the complexity that's happening at the runtime and infrastructure level from your developers. So this is sort of just setting the scene of where we are today. So depending on what messaging infrastructure you're using, what databases you're using, where you're deploying your applications, typically that's going to end up bleeding into your developers' inner loop and slowing down their productivity. So for today's talk, Matt and I are. Can I call you that? Is that okay?
Yeah.
We're going to be playing two different roles, and these are two roles that work very much together in the cloud native space, and on most teams, I'll be playing the role of basically an application developer. And ultimately, let's say I'm a full stack developer and I care about being productive. I want to be able to build innovative applications quickly, and I don't really care necessarily what the underlying infrastructure is that I'm using. I don't want to be rewriting common patterns. I don't want to be implementing complex resiliency logic. I don't want to be rewriting stateful processes and workflows and actors when those things already exist, right? I want to be enabled to be able to write code that actually provides value to the business in which I am in. So yeah, and then we have...
Yeah, and I'm a platform engineer, and I have the mandate with my team to build a platform, an internal developer platform for my company, right? The goal is to collaborate with cloud engineer, network engineer, security engineer, with observability team, and the goal is to make sure we have standard. We are standardizing template. We are standardizing governance, security, and we are going to have more automation. The goal for this is better collaboration, as well as enabling the developer to focus on their productivity. They want to ship value to the business, to the end user. How we could help them and avoid what we call the cognitive load. How we could reduce the friction for them to adopt the platform, to use the platform.
Also, we're going to be the first people to say developer productivity 300 times. So get ready for it. That's what we're all here for, right? So yeah.
And yeah, as platform engineer, again, we were looking for, and we are looking for some framework. And the CNCF platform working group has released a couple of white paper and framework that you could use. And the first one on the left is about, what about the building blocks of my platform. I'm building an internal developer platform, but there is already existing tools, security, observability, how they connect to each other, how the team and the processes are interacting with each other. So with that, you will also focus on now, could we deliver capabilities on top of that? That's what you could call seeing your platform as a product as well. And based on that, you could also look at some friction, some pain points, some rooms for improvement. And that's where the maturity model is very interesting, because you could see where you fit and on what you want to focus. And today, we want to focus on the interfaces between the developer and the platform, right? And Dapr and Score are very a good fit for that, and we will demonstrate that today.
So the question then becomes, and can you all still hear me okay? In the back? Okay, perfect. I just wanted to make sure. So Dapr and Score both have ways in which they enable developers and platform teams to work together through this concept of standard interfaces. So if we focus on the developer perspective, Dapr essentially provides a set of APIs and SDKs that developers can use to consume the underlying capabilities of the platform. In the same way, developers can author Score specifications to essentially claim and or tell the platform what it needs, what dependencies its application has, without having to understand how that's actually going to be implemented on the back end. So when we bring the platform capabilities into the picture, there are also interfaces that these projects provide that are focused more on standardization at the platform level. So how do I, as a platform engineer, actually expose the capabilities that are then consumed by the developer-facing interfaces? And that's where you get into things like Dapr components, the control plane, things like that, and the Score implementations. And these might be abstract concepts if you don't know what Dapr and Score are, but luckily that's what you're here for today, is we're going to dive into these primitives and explain how they all fit together. So, who's excited? We're about to get into some code. We love that. Yay! Okay, great. So, I just wanted to give a quick Dapr overview if you're new to Dapr. How many of you have heard of the Dapr project before? Okay, wow, love that. That's great. So Dapr is actually a graduated CNCF project, which is super exciting. We graduated right around the time of KubeCon over in Utah last year. And ultimately what Dapr provides and how it runs is it's a sidecar model. So it's traditionally deployed onto a Kubernetes cluster injected into application pods. And it essentially exposes a set of standard APIs that developers can use to build microservices applications without having to concern themselves with rewriting common patterns and architecture styles. So this can be everything from service invocation with MTLS, similar to a service mesh. It provides things like abstracted state management. You can do publish subscribe mechanisms. You can build large-scale stateful workflows using the Dapr sidecar. So that's just what I wanted to call out, right? And all those APIs are essentially that developer interface, and then the underlying platform teams can actually configure those APIs to reach out to various infrastructure services. And so that's really more on that platform capability layer. So let's say we're standardizing on Dapr. Let's just talk from a developer perspective. So I'm authoring my applications locally, as most developers do. And here we can see on the slide a large image of basically just like a basic Redis implementation, right? I'm using the Redis client. I'm making a call, storing a key value pair, and then ultimately I'm going to read that, right? So we can see here I'm taking dependency on Redis. Maybe not that big of a deal if it's, you're writing one simple project, but if you think about the number of dependencies that your developers continue to take on explicit infrastructure services, and this could also be things like libraries for resiliency and other things, right? As you're distributing your applications, more and more concerns, you have to build your application to be fault tolerant. So all of this bleeds into the application code, which once again, for a small application might be okay, but that tight coupling is not always very valuable when you're trying to standardize. So let's swap that out. So now we're taking a look at what it looks like to use the Dapr SDK to accomplish a similar objective. So here we can see there's no Redis, there's no specific infrastructure logic. We just see we're importing the Dapr client, and then we're ultimately saving state. Now, the unique part of this, which Matt will explain here in just a second, is that you can see I'm using the client to save state, and I'm passing in this concept of a state store name. What does that state store actually mean? I, as a developer, might not really care, right? I want to store a key value. Pair, I don't really care necessarily where that's being stored as long as I know it's secure, and that's really not my job to have to worry about, hopefully, right? If we're focused on enabling developers to offload some of the security and infrastructure concerns to a lower level, right? Not the reality of today, always, but it's something that we're trying to accomplish, right? So you want to explain this a little bit more?
And that's where you could see the very first point where Dapr, with the notion of Dapr component, is helping us. We want this streamlined, seamless integration between, hey, I'm talking to a state store. Is it Redis? Redis locally? In Azure? Is it a Postgres database? So here, as platform engineer, I have the ability to author some recipe, some component, and the developer won't change anything on their code. They just reach a state store, whatever the technical implementation is.
Awesome. So these components are loaded at runtime by the Dapr sidecars that are running, and they can be scoped, they can be governed. So there's a lot of additional capabilities that I would love to talk to you about after the session. So now that I've written my code, I have my components available, this is where I really get into actually running the code locally, right? Some kind of inner loop development. And this is going to look different for every developer. If you're a print line person, a debugger person, we can talk about that later. This is something we've been talking about this week on my team. But ultimately, I'm going to do a Dapr init, which is essentially going to install Dapr onto my local machine. And it's going to make use of Docker to actually give me a few control plane services, which are used in order to facilitate the inner loop. So for example, I have an actor placement that will run as a container. I have a scheduler, which is going to help me manage stateful workflows when I'm doing local development. And then I also get a couple things out of the box. I get Zipkin for tracing so that I can immediately see all of the OpenTelemetry traces being sent across my local services. And I also get a default Redis instance, which I can use for a default component implementation. So I start publishing messages, it can use a default Docker container on my machine. And then ultimately, once I've initialized my machine, I'm going to do a Dapr run. What this Dapr run is going to do is essentially it's going to run all of my applications locally using the application commands and the appropriate ports. And it's also going to launch a sidecar process, which acts as the Dapr intermediary layer, right? So those sidecars aren't actually running containerized on my local machine. They're just a sidecar process. Awesome. So now we're going to get into an actual example of some Dapr code. I'll be quick and brief, but hopefully it will be a good explanation for you. I hope the screen's not too blurry. But basically, it's going to be an order process workflow, nothing super crazy. Basically, we're going to submit an order. That order is going to kick off a Dapr workflow. It's going to do a few things. It's going to reserve inventory using a Dapr state store API. It's going to essentially determine if the order is over $1,000, and if so, it's going to wait for approval, which is just another function of the Dapr workflow implementation. If I give approval or if it's under $1,000, we're going to process payment, we're going to process shipping, and then ultimately, depending on the outcome, we're going to complete the workflow. Sound good? Sweet. Okay, I'm going to make sure this is zoomed in pretty well.
Perfect.
Let me close these out. Can everyone see my screen okay? How's the text size? Perfect.
Good.
Okay, so I'm not bold enough to do a Dapr initialization right here because I don't trust the Wi-Fi. So I have already done Dapr init on my machine. So I just want to clarify, this is exactly what I said. We're going to do a Dapr init. Right now, it's not allowing me to do that because it already exists, right? So if I do a Dapr uninstall, it will remove all those control plane components. It will basically remove the runtime from my machine, and then I do a Dapr init, and it gives me everything we mentioned. So we can do a quick Docker PS, and let me close that out. If we do a Docker PS and we basically just grep for the Dapr containers, what you'll see is exactly what I just mentioned, right? We see that Redis instance, we see the placement service, we see the scheduler. Just wanted you to know that they are there. And then ultimately, from there, I'm going to do a Dapr run. So let me confirm. Yeah, let's go ahead and close that out, clear this out. So I'm going to do a Dapr run. And this Dapr run is using the YAML manifest that's in my repository. And I'm very zoomed in because I want y'all to be able to see, but I'll just zoom out for 1 second. This is that Dapr YAML file I was mentioning. So this is going and launching that workflow. That workflow is coordinating multiple calls across other services. It's calling to a payment service. It's calling to the shipping service. And ultimately now everything is up and running. We can see in this output, the blue output is my application runtime essentially logging, and then the white is all of the Dapr sidecar logs, letting me know that the app ID is up and running and the sidecar is ready to go. So before I get into a quick code tour, I do want to show you just like a running workflow. So the first thing I'm going to do is I'm going to get the current inventory. This is using the Dapr API for state. You can see right now we have no inventory available, and I just want to confirm that to you for you in Redis, right? So I told you I'm using a local Redis component. It's hooked up on my local machine. It's running in Docker. So I haven't stored any data. What I'm going to do, I'm going to make an API call to my application to restock inventory. Under the scenes, this is using the Dapr API to go save that key value pair. And then if I refresh my screen here, we should see that we now have our inventory items, right? So like I said, code doesn't have any Redis in it. We're going to see that in just a second. But we now have inventory that we can essentially use as part of this order process. So now what I'm going to do is I'm going to submit a simple order. What this is going to do is going to call a controller method. That controller method is essentially going to start a workflow using the Dapr workflow SDK, which you'll see in just one moment. And I just wanted to kind of show you this so we could actually get a demonstration of the workflow running end to end. So let me pull back up. So you see here, I have a UI in this service. I have a notification service that's subscribing to every activity within the workflow. So whenever a workflow processes payment, when a workflow starts. So you can see here, I kicked off the workflow and I subscribed and received all of these messages using the Dapr PubSub API. So now I want us to walk a little bit into the code itself. So everything's up and running still, good to go. So let me just switch over here and I'm gonna do a quick code tour. So the first thing I want us to do is take a look at the workflow code. So let's close all this out, create less noise for you, and then we're gonna zoom in. So you can see on line 25 here, this is where I'm importing the Dapr clients. So I have my Dapr clients who make PubSub calls, to make service invocation calls, to save state. And then I also import the Dapr workflow SDK. What this is doing, by the way, when the sidecar comes up, is it's establishing a gRPC stream from the application to the sidecar. And there's a constant gRPC stream that's sending the work items to and from that sidecar, which is hosting the runtime, so the workflow runtime. So after we have imported Dapr, which is great, we also have to register our workflow. So I'm basically going to start the workflow runtime. I'm going to register my workflow and all of the activities it should have access to, and then I'm going to start the workflow runtime. And that's what's really managing that gRPC stream and making sure that the activities that need to be executing as part of this workflow are occurring. So after I've done that, let's take a look at the actual workflow definition. Can you all see the screen okay? Is it kind of zoomed in enough where you can read it? Perfect. So we see we have a process order workflow. I'm not going to go through every step. We talked about it conceptually. The big thing is that workflows don't actually do any computation or processing, right? They actually offload that to activities. So the main idea of the workflow is that it creates the structure in which things are executed, and then ultimately the activities are actually doing the processing, making external requests, so on and so forth. So let's just take a look at two things. I want you to look at two things. So the first one is the notify activity. That's what's publishing the messages you saw on the UI. And then we have the inventory activity down here, where we're basically going in and saying, right here, line 75, you can see we're reserving inventory. So we're gonna look into those two activities, and then we will pass it over to Matt to get into score goodness. So let's take a quick look at these activities. So the first activity we're going to look at is the notify activity. I want you to consider, has anybody implemented any kind of message broker or message streaming? Perfect, great. Fun? Complicated? Involved? Yes. So if you can see here, yes, this is a basic demo, but you can see I can use a Dapr client to publish an event. Dapr supports over, I believe, 25 different PubSub brokers that can all be communicated with and configured using components behind the scenes, but the code stays the same. So I just want to publish a message, and I want to use any given number of infrastructure providers. Dapr is going to handle that for me on the back end. All I have to do is publish a message, and once again, tell it what the name of the component is that I want to use. After we take a look at this, I want to actually show you here how this is working, right? So this works because we set up this component. So I'm saying I want you to go talk to Redis. You don't have to put it directly in the code. I'm using the component here. And then we also have a subscription. And what you'll notice is in Dapr, there's multiple ways to do subscriptions, declarative, streaming, code first. But you can see it's referencing that PubSub component. So I'm basically saying I want to subscribe my app to the PubSub component called PubSub. And then last but not least, we can see where that message is getting delivered to the UI. So we can see, hey, I'm receiving the messages that are being published because I'm subscribing, and I'm going to display those to the end user. Another quick look at Dapr usage is basically, in this case, we're making an invocation request. So we're actually going out and invoking a secondary service, another microservice, using Dapr. You get MTLS out of the box with this. You can set access control lists. So it's really a powerful API. So you can see here we're invoking a method called inventory on the, on the app called inventory on the inventory reserve endpoint. And then last thing I wanted to do was just show you what that endpoint actually looks like. And you can see here we're using the state API to get state or to save state. So once again, very, very much a standard API surface when you're using Dapr across your applications. So perfect. Now I'm going to switch back over to these slides here. I think we're doing fairly good on time. So let me play from current slide. So this is great. Like, we've seen Dapr can be very powerful. It has really powerful programming models. However, there are some challenges. Like, I did Dapr run on my local machine, but how do I get this into like a containerized version, right? How do I go deploy this into staging or production? How do I actually take this into Kubernetes, right? I'm not just going to go deploy my Dapr run file. I need Kubernetes manifests. And so this becomes a problem that typically developers are now having to face, right? Running local Kubernetes clusters or trying to figure out how to hobble together dependencies in Docker Compose for testing purposes. And so that's really where I'm struggling from a development perspective, is how do I now go from inner loop to the next level?
And I think we have an idea in my team. So as platform engineer, what we have is we have now the developer empowered to deliver value to the business, right? Now, how we graduate, how we promote, how we deploy via CI/CD pipeline, maybe in development environment, staging, production. So we want now to help the developer to deliver value concretely at the business, right? And also, we want to avoid the, hey, it works at my machine. How it will, why it's not working in production, for example, or in dev or staging. So we want to collaborate closer with this Dapr component and this integration. And again, we want to do some recipes to automate more. So here, the goal is to say, yeah, you want to go in production, our platform is hosted on Kubernetes. So you will need to have a Docker file, maybe. Then you will have the CI/CD pipeline. Maybe you want to do some Docker command to run the container, to test the container, to deploy it. Then you will have maybe a compose file in order to integrate some components and database and pub/sub and the different components talking to each other. And then you may want to author some Kubernetes manifest, how they could provide information in order to deploy that in a Kubernetes cluster. So here enters Score. Score has two concepts. The first one is the Score specification. That's where the developer will focus on describing the intent to deploy their workload or their workloads, right? And they will describe, hey, I need a dependency. I need a state store, please. Right? And I will show you an example very quickly. The second aspect of Score is the concrete implementation from this very workload specification file, which is agnostic to the platform, agnostic to the environment, development, staging, or prod. Now, how I concretely implement, how I deploy this request. So here come the Score implementations. Some of them could be Docker Compose as a target runtime, Kubernetes, Fly.io, Humanitec, and others. And I have also the opportunity as platform engineer to author recipes for Postgres, SQL database, Redis, Mongo, name it. Is it local on Docker? Is it local in Kubernetes? Is it in Azure, in GCP? I will be able to author this kind of recipes. And having this notion of standardization on the right, but also the abstraction on the left.
So if I'm a developer, and like I said, I have this challenge, I want to be able to get my workload somewhere where it has the dependencies it needs, but I need to graduate from my local development machine, I don't really want to have to worry about Docker Compose. I don't really want to have to worry about Docker files. I don't necessarily want to learn Kubernetes. So instead, what I can do is essentially author this Score file. Looks probably pretty familiar. It looks like a Dapr YAML. It looks a little bit like Kubernetes YAML, but it's very succinct. It's very clear in terms of what the developer needs. And you can see here, I'm basically asking for a resource, right? I want a Dapr state store. I don't really care how I get it. I just want one. That's what my app needs.
And here, again, as platform engineer, I will support the developer with an implementation, a concrete implementation. And here we agreed that, hey, let's do the first implementation and use the first implementation with Docker Compose. So here it's a recipe to inject the sidecar container, the placement container, all of what Dapr needs in order to successfully run their application as developer. So that's the implementation part. And I mentioned the resource provisioner, how concretely I will provision Redis as a container, how I will inject the component associated to that. So here, I won't go too much in detail, but that's how you will author your recipes as platform engineer. And then the workflow is Score Compose init, in this case. It could be Score Kubernetes. There is another implementation. And you init your current state, current local machine, and you do Score Compose generate on the Score file. And guess what? With a targeted implementation, Score Compose, it will generate the compose file. So now I could run the third command here, Docker Compose Hub. And now I have all my container built and run successfully locally, and I could test my application. So let's do the demo here.
Yeah, I can talk to this slide well. So ultimately what we're going to show now is going to be a little bit of what I did, but we're now graduating environments. So as we talked about, you can swap Dapr components, which is really nice. What Matt's going to show us is how essentially without having to author any Docker Compose, we can take that same application, we can take those Score files and essentially run them in Docker Compose with 2 Redis instances for pub, sub, and state. And then we're ultimately going to use those exact same Score specifications from a user perspective to run that workflow, that workload and workflow on Kubernetes, but then we're going to swap out the components. So a user is going to get Postgres, for example, in the staging environment instead of getting a Redis local instance, but the developer code and the developer specification doesn't change at all. So Matt, I'll hand it over to you.
Wonderful. So what I want to show you here is very much the Score file. The first Score file that you want, maybe, is with the notification workload. You remember the 5 microservices that Kendall showed you? That's a Score file. I will be able to describe the intent of and the metadata, the information for my workload, the port it will run on. But look at this. I'm also asking for resources. And the resources we could see here is, for example, I want to subscribe to a PubSub, right? And now what I want to show you is another example with the inventory. Same, I'm describing the intent of deploying my workload inventory on another port. And here, I will have this Dapr state store. And I ask for a state store, right? So that's on a developer perspective. Now what I want to show you is kind of the workflow very quickly with Score Compose. So again, please generate the compose file based on all the Score file, right? And with the implementation provided by the platform engineer, the developer will be able to generate that seamlessly. It's abstracted. But guess what now? I have now a very complex compose file. So here, with this core implementation, Score Compose, I'm not asking my developer at scale to write 300 of line of Docker Compose and know the technical detail about Redis database, state store component, and all the relationship between the workload. So here, again, it's generated, abstracted. And then we could do Docker Compose up. And I have all the container running. And now I could check that I have 2 Redis databases, one for the state store and one for the PubSub. That's the default setup. Now what I want to show you very quickly is I could open the notification page. I'm running on Docker, and now I'm deployed via Score file and Score, right? Here, what I want is generating traffic. So I'm locally, all the Docker are running, and I'm generating traffic to the notification and talking to 2 Redis database, right? So that's the first step, right? Again, as a developer, I don't know the technical detail. I'm just deploying my Score file. The second part of the demo is, let's move on in the CI/CD pipeline, right? I want to push to development, staging, and production. It will go throughout a CI/CD pipeline, but here for the demo, let's illustrate this. So here, again, please, could you generate the Kubernetes manifest for me, right? As a developer, I don't want to do that. So the platform engineer were able to provide the recipe using this core Kubernetes implementation, and guess what? Again, it's generating a Kubernetes manifest file with a lot of Kubernetes resources. And here I have 600 of line. Again, developer shouldn't take care of that and deal with the technical detail. Is it secure? Am I injecting the right label annotation? So
spacing,
here,
tabs, all the things. Don't have to worry about it.
Exactly. So now I will be able to push and deploy this in my cluster. And now I have Postgres and RabbitMQ. So what we did also as an exercise here is I want to graduate. Redis is good for the inner loop, fast, but now we want to use Postgres. We want to use RabbitMQ in production, maybe with Azure, with any cloud, right? And I put together, as platform engineers, the recipes behind the scene. The developers, they don't change the code, they don't change the Docker file, they don't change the Score file. And now, guess what? I have a new application deployed, right? And I'm generating traffic. Sorry about that. And you could see I'm now on Kubernetes at the bottom, using Postgres for the state store, RabbitMQ for the PubSub, and now it's still working. So we have this seamless deployment process in place now.
I think one thing that's important, I know we're at time, but one thing that's important to consider, right? Our goal isn't to make it where developers don't have to use their minds, right? Like, that's not the goal. The goal isn't to create an abstraction that's so black box that people are resistant to it, right? Because that's a reality as well. So you have to empower developers to understand the tooling, to be able to educate themselves on how to break the glass, but also to not have to be inundated with worrying about this day to day. So hopefully that gave you a good picture of how Dapr and Score together can create a pretty compelling experience. We would love to connect with you the rest of the conference. There is a Dapr open source booth. I believe Score also has an open source booth, so please come to see us. Please come see us at the Diagrid booth as well, and I believe
we have a Humanitec booth as well.
Perfect. Yeah, so we would love to connect. If you have any questions, we'll stick around.
Yeah, thank you for your time.
Thanks.